Ferrous metals are alloys containing iron. Most are magnetic, though some are only weakly so. The name ferrous comes from the Latin word for iron, ferrum. This bike is made of different ferrous metals. The muffler is low carbon steel. The chain is medium carbon steel. And the springs are high carbon steel. The brake disc is cast iron. The plastic hydraulic lines are protected by braided stainless steel. And the forks are chrome moly. And some of the tools used for making this bike would have been tungsten alloy. We are going to look at these different steels and see why they are used for different jobs. In the Stone Age, it took a week to cut down a tree. With the discovery of iron, a steel axe did the job in 1 hour. Iron had a tremendous impact on lifestyle and food production. It was one of the most important changes for mankind. Today, iron is the backbone of the world we've built. It is strong, plentiful, and cheap. Iron comes from iron ore, such as hematite, which is similar to rust. It is a combination of iron and oxygen. The oxygen is removed by heating the ore with carbon from coke. The carbon removes the oxygen, leaving iron. But there is still some carbon left, and this affects the properties of the iron. So the carbon content has to be adjusted carefully. In a second furnace, oxygen is blown through the molten iron. The oxygen burns up carbon, allowing the steel makers to adjust the amount of carbon. Iron and carbon are known as steel. The carbon content affects the properties. We have pure iron, low carbon steel, medium carbon steel, high carbon steel, and cast iron. The low carbon is soft and easily scratched. The high carbon is much harder. So high carbon steel can cut low carbon steel. Pure iron is as soft as butter and can be bent cold into any shape you desire. Once it is bent, its work hardens a little. When we bend it like this, we call it wrought iron. It's good for decoration, but it's not very strong. Mild steel is the most common steel. It has from 0.1 up to 0.3% carbon. It is not terribly strong, but it is safe to use as it will bend without breaking. Steel cans are made of mild steel with a very thin coating of tin. We prefer a can to bend and distort rather than crack and break open. We can drop cans without damaging the contents. It's 1937. An expedition has set off to explore the highlands of New Guinea. They had a problem as the local people had very little spare food, and they were going to be in the bush for 18 months. They used aeroplanes to deliver supplies in the world's first airdrop. The tins were shaken and thoroughly stirred. And today's expeditions are often supplied by airdrop. Even though the mild steel cans are bent, they are mostly able to protect the contents from spoiling. The worst that can happen is you lose the labels and eat lucky dip each night. Cars too are made of mild steel. If a car is going to crash, we want the metal to bend and absorb the energy of the crash. Mild steel is easy to weld without damaging the properties of the steel. It is difficult to weld high carbon steels without changing the carbon content around the weld. Guitar strings are made of medium carbon steel. Medium carbon steels are in the 0.35 to 0.5% carbon range. They are stronger and harder to bend. They're used for cables and wires and train tracks. High carbon steels range from 0.5 to 1.5% carbon. They are almost impossible to bend without breaking. This gives the rigidity required in a needle. If you need something to stay sharp, you'll need high carbon steel. However, if it is too hard, it will chip easily. With 2.5 to 4% carbon, it is cast iron. It is very hard. Very few things will scratch it.
We use cast iron for disc brakes because it's hard and doesn't wear easily. And when it's hot, it doesn't soften or distort as easily as mild steel does.
But cast iron is brittle. You can't afford to drop it. It must be handled like glass. Here, we are clamping a sample of cast iron into a machine for testing tensile strength. As the clamps tighten, he was lucky. He should have been wearing a safety mask, or he could have lost an eye. Water-cooled engine blocks are made of cast iron. One of the reasons is that it doesn't rust. It has silicon in it as well as the high carbon. Cast iron is used a lot outdoors because it doesn't need to be painted. Nowadays, a lot of decorative cast iron is being replaced by cast aluminium. As well as carbon, metals such as chromium, nickel, molybdenum, tungsten, and vanadium can be added to modify the properties of the steel. These metals mixtures are called alloys, and the proportions can be varied to produce an alloy with particular properties that you want. The main types of steel alloys are stainless steel, chrome molybdenum steel, and tungsten steel. Stainless steels are the most used of these. These contain from 12 to 18% chromium and up to 10% nickel. The 1810 label on this saucepan means 18% chromium, 10% nickel. The biggest advantage of stainless steels is that, unlike plain steels, they don't rust. The knife at the front with the rust is steel. The other knife is stainless steel. On the surface, chromium atoms react with the oxygen to form a very thin oxide layer, which protects it from any further corrosion. Stainless steel is used a lot for food processing because it doesn't rust and contaminate the food. Stainless steel does have a weakness. It is corroded by caustic soda, which is sodium hydroxide. Stainless steel used in hospitals has to have extra chromium in it to resist the salt in body fluids. And if it is in contact a lot with salt water, it will suffer chloride cracking unless it has molybdenum included in the alloy. Molybdenum is the moly in chrome moly, the common name for low alloy steels containing chromium and molybdenum. Chrome moly has great tensile strength. This means items can be made thinner and lighter. This is a custom-made recumbent bike. You sit back and push forward. The frame needs elasticity to flex back and forth to provide a softer ride. And the alloy metals improves the material's ability to do this without cracking.
For this member here, it's relatively thin wall and large diameter because it's copying smooth loading of the pedaler pedaling back and forwards, back and forwards. This member here is copying the road shock each time a bump hits the tyre. This member gets moved up and down, so it's going to be moving a lot, so it's thicker wall and thinner diameter.
Chrome moly is now also finding a use in products like these gas cylinders. The walls can be made thinner and still safely hold gas under enormous compression. Lighter cylinders are cheaper to transport. Adding molybdenum to the rail tracks in this iron ore mine has greatly increased their working life. Before this, the carbon steel rails were wearing out quickly. The cost is not just the steel, but the labour to replace it, and the loss of production while the track is out of action. Tools used to cut steel have to be extremely hard to keep their cutting edge sharp. But the heat generated by high-speed machining can soften them, so tungsten is added. Tungsten has the highest melting point of any pure metal, 3,380 degrees Celsius. A high-speed tool steel may be 18% tungsten, 4% chromium, 1% vanadium, and 0.75% carbon. If we bend a piece of steel back and forth, it undergoes work hardening. The working rearranges the inner structure of the material. It becomes more and more brittle and eventually snaps. Heat treatment can modify the properties of steel and minimize the effects of work hardening. This steel needle is tough and springy. Let's see what happens if it's heated to red heat, then left to cool slowly. This is called annealing. After annealing, the needle bends, and notice that it stays bent. It's lost its springiness. Let's now heat another needle, but then cool it rapidly. This is called quenching. It's now hard and brittle. This needle was also quenched. Now we'll heat it moderately till it just begins to change colour. Then let it cool slowly. This process is called tempering. Tempering removes brittleness while retaining the hardness required in the material. These golf clubs have been tempered to reduce brittleness, but retain the other qualities of the steel. The crystalline structure produced by quenching is called martensitic, after a metallurgist called Martens. Annealing, slow cooling, produces a different structure that's called austenitic, after another metallurgist named Austin. We are going to look at the physical properties of carbon steels. In choosing the carbon content, you are making a choice about hardness, strength, and toughness. Tensile strength is the strength in tension, that is, a pulling force. To test tensile strength, you put a sample into a tensometer and pull until it breaks. This sample of mild steel broke at about 8 kilonewtons. The cast iron breaks at about 5 kilonewtons. So although cast iron is harder, it is weaker in tension. On a larger tensometer, it is possible to see how mild steel behaves under tension. At first, it stretches elastically. That is, it will return to its original shape when the load is removed. Then it passes its elastic limit at the yield point. Any stretching beyond here is permanent. The sample necks and then ruptures. Comparing it to an original bar, you can see how much it has stretched. Toughness is a measure of how much work it takes to break a steel. If it is strong and also bends a lot before breaking, then it takes a lot of work to break it. This machine allows us to compare the impact strength or toughness of various metals. Mild steel distorted a little and absorbed the energy of the weighted pendulum. It is very tough. Now cast iron. It snaps easily and there is even energy left over. So although it is hard, it is not tough. It can't absorb energy because it doesn't stretch before it breaks. Brass is similar to mild steel. Malleability is the ability of steel to be distorted by compression or squeezing. How easy it is to be rolled or hammered out into a thin sheet. The malleability of steel varies with its carbon content. It is very malleable when it is red hot. When steel sheet is being pressed into shape, it needs to be malleable, and it needs to be ductile as well. Ductility is the ability to stretch. The melting and softening point of metals varies a lot. A drill point may get hot, so it must have a high melting and softening point. When steel is left exposed to water, it rusts. This is a chemical change. The metal reacts with water to form a metal oxide. This is a different substance, with completely different properties. It's broken down into a crumbly, weak oxide. This is a rear brake cylinder in a car. Moisture in brake fluid has rusted the surface. It may not look like much, but brake fluid can leak past the piston. This could mean brake failure. Very occasionally, surface rust is used for artistic effect. This Picasso, and the building behind it, are made of a steel containing a little copper. It is designed to form an oxide coating that protects the steel and has no need for painting. Steel is often protected from rusting by dipping it in molten zinc. This is known as hot dip galvanizing. The zinc oxide protects from further corrosion. Here, sheet steel is being coated with molten zinc and aluminium alloy, zincolin. Chromium plating works the same way. A layer of chromium oxide prevents corrosion. So, when you are choosing a steel for a job, you need to consider the properties of the steel and work out which is the best for the job. Of course, cost will always be a factor. It may be cheaper to simply replace bits, or make the steel thicker and let it rust. Or perhaps the cost of having a critical machine fail may be so high that the cost of the material in the part will be insignificant, and you can choose the very best.